This is the lesson for Tuesday, October 8th, and this is a lesson on solubility rules. It's a really important concept in chemistry because it's going to tell us when we get to various chemical reactions whether they would actually take place or not. You're going to need several things for this. The first one is on the back of the assignment, you have the solubility rules, so you really don't need to have your blue sheet, but it's helpful to have that. The other thing you should have for this assignment is the periodic table of charge numbers. It shows you what the possible charge numbers are on the different elements. The other thing you should have is the orange sheet with the 60 common ions, this one. And of course, you should always have a periodic table laying around, okay? May or may not be useful, but it's kind of the centerpiece of chemistry, so we usually have that there. Okay, so what we're going to do is just very simply, these first roughly 20 or so compounds, we're going to determine whether they're going to dissolve in water. So the solubility rules that you have are for water, and I asked you to write that down. And go ahead and write that down. These only apply to water. Wouldn't apply if you put any of these things in an acid or in a nonpolar substance such as alcohol or oil or anything like that. It just applies to water, but water is the most common solvent by far. There's not even a close second. So we want to be sure we know how things behave when they're put in water. Okay, so let's get started. First one, lithium hydroxide, LiOH. So you look up here. And lithium is soluble always. The alkali metals, the ones way over on the far left of the periodic table, they break off with anything. So the exceptions for all anions is anything with a negative charge. These are positive charge. These are exceptions. They're insoluble. So any anion down here that says it's insoluble, the exception would be any of these four right here. So lithium attached to anything is going to dissolve. It's going to break apart. So that means it's soluble. So if you want to write this just as what does it mean? It means it's going to turn into a lithium ion and a hydroxide ion. It's going to break apart into those two things. You don't have to write that part every time. It's just to be sure you understand what's going on. Okay, next up is silver bromide. So we look down here. And we see that chlorine, bromine, and iodine are soluble with everything except three elements: silver, mercury, and lead. So silver bromide is one of the exceptions to bromine being soluble. So that's going to be insoluble. This compound right here is insoluble. Means it will not dissolve. It'll stay together in water. All right. Lead sulfate. Let's see what happens. Where do we find sulfate? And over here in the soluble column, we see sulfate. Sulfate is soluble, but except for 5 elements, it won't be soluble. So it's insoluble if it's attached to any of these 5 things. Lead is one of those. So lead sulfate is insoluble. You put it in water, it'll stay together. Next up is sodium hydroxide. Sodium's one of those that's always soluble no matter what it's attached to. There it is right there. It's also on this side. So sodium hydroxide will dissolve. That is soluble. We're actually going to do a lab where we dissolve sodium hydroxide and measure how much heat comes out of it when it's dissolved. Okay, next is barium sulfate. So let's look for sulfate. There it is. And just like was the case with lead a couple problems back, barium is an exception. So when barium is attached to sulfate, it is insoluble. So again, be sure you understand soluble. SO4 is soluble with anything except these 5 things, and then it's insoluble. So that's going to be insoluble. Iron sulfate. So we come down here, sulfate soluble with everything except these 5, but iron is not one of those 5. So these would make it insoluble, so it is soluble when it's with iron. Okay, magnesium sulfide, MgS. So we come over here and sulfide or sulfur or sulfide is insoluble. You're in the insoluble column right now. So this is insoluble except when it's attached to any of these three things, in which case it's soluble, or if we're attached to any of these as well, it would also be soluble. Okay, these up here take precedence over everything else, that these guys are always soluble, these guys are always soluble. Okay, but anyway, this is insoluble except when it's with one of these three things, or one of these. But magnesium is not one of those, so it's insoluble. It's not going to break apart from magnesium. Okay, lead iodide. So we come over here. Iodide is always soluble. It's in the soluble column over here. It's soluble except with these three elements, and lead is one of them. So that means it's going to be insoluble. Okay, barium hydroxide, come over here. Hydroxide is always insoluble except with one of these three, or one of those four up there, but one of these three. But let's see, that's barium. Barium is right there. So this is insoluble except when it's with barium, so it is soluble now. Okay, tin hydroxide. So there's, it's SNOH2. Again, the fact that there's two OHs doesn't change anything. It's OH, it is a hydroxide. So it's with tin. So what does it say here? You're in the insoluble column. Hydroxide is insoluble except with these three, but tin is not one of those three, and it's not anywhere up here. So that means it's going to be insoluble. Okay, KCl. Well, there's K right up there. So right away, you know it's going to be soluble. So KCl is soluble. Potassium. All right. Calcium carbonate. That's what the eggshell is made out of. The eggshell would not dissolve if you put it in water. Let's say you wanted to boil for hard-boiled eggs for Easter or something. The shell would not dissolve, but it dissolved because we put it in acid. But we're not interested in solubility in acids. We're interested in solubilities for water. So anything that's a carbonate here, unless it's with one of the major exceptions up there, it's going to be insoluble. So this is insoluble. Next up is sodium phosphate. So we come down here, phosphate is insoluble, but it's with one of the big exceptions, sodium. So you say, well, which takes precedence? This is the exception for any anion, including phosphate. So this is going to be soluble, okay? Okay, copper hydroxide. So hydroxide is insoluble except when it's with one of these. It's not, copper is not on that list, so it is going to be insoluble. Okay, silver sulfate. So again, we go over to sulfate. And sulfate is soluble except when it's with one of these five. And silver is one of those five. So that means it's going to become insoluble. Okay, calcium sulfate. It's going to be sulfide, calcium sulfide. So sulfide is insoluble except when it's with one of these three, and calcium is one of those three, so that's going to make it soluble. Okay, this is mercury nitrate. So we come over here and we see nitrate is in our soluble list. There's no exceptions anywhere. So that is going to be soluble. So mercury nitrate is going to be soluble. Okay, next is potassium iodide. And of course, potassium is one of our major soluble alkali metals. So that's going to be soluble. The moment you see alkali metals, it's pretty much there as being soluble. Okay, this is ammonium bromide. So we come up here and ammonium is in this list, and it's in both of these lists of things that are always soluble. So you don't have to look any further, that's soluble. Okay, and finally we have silver iodide. So we come over here, and iodide is in the soluble column, so it's soluble always except for these three, and silver is one of those. So silver iodide is insoluble. So as far as I'm concerned, you'll always be able to use this list in class and on tests when I do eventually test you on this material. Okay, let's move on. Now, I'm going to ask you to do something a little more sophisticated. I'm going to give you two elements and just their pure element name. I'm going to ask you to figure out how they combine, give the chemical formula. If there's more than one possible chemical formula, I'm going to go with the simplest one, the one that has the least number of atoms. Then I want you to give the name for them. And then I want you to state, based on what we just did up here, is it a soluble compound or not a soluble compound, okay? So sodium and sulfur are going to combine to make sodium. And sodium is a plus. And this is where our periodic table is helpful. So sodium is a +1 because if it gives up one electron, it becomes like the noble gas neon. So it's a +1. Let me actually get my charge sheet out here. Sodium is a +1, and sulfur is a -2. So sulfur likes to catch 2 electrons. It wants to catch 2 in order to bond. Sodium only throws out 1. So you need 2 of these guys throwing off electrons to make this guy happy, okay? So 2 sodiums, each one throws off 1 electron. That's a total of 2 electrons. And this guy catches both of those electrons. So it's Na+, and I'll take away the plus sign. It's Na2. You need 2 sodiums for 1 sulfur. Okay, it's an ionic compound, so you don't use mono, di, tri, any of that stuff. It's just sodium sulfide. It's not 8 or I. That's when you have oxygens, carbonates, sulfates, all that. That's when you have oxygens involved. No oxygens here. Is it soluble? Well, it's got sodium. You bet it's soluble. Okay, there we go. Right there, right there. Sodium is soluble. Absolutely. Okay, next is lead and chlorine. So we come over here and we see that lead, which is Pb right here, can either be a 2+ or a 4+. If we can, we're going to use the smaller one. Okay, and the other element is chlorine here. So each chlorine likes to catch 1 electron. And each lead, if we use the simplest one, likes to throw off 2 electrons. So this lead, the simpler of the 2 leads, is going to throw off 2 electrons. So it takes 2 chlorines to catch those 2 electrons because each one only wants to catch 1. So you have 2 chlorines and 1 lead. Remember the rule, though, we said you can take that and move it over to the subscript there and take the -1 of chlorine and move it over to the subscript of lead. Remember how you can do that kind of crisscrossing arrow thing? Okay, so here we go. So we have lead, Pb, Cl2. You don't show any plus or minus signs because at this point, it's electrically neutral. It has the entire compound here has an equal positive and negative charge. So there's no plus or minus signs there. Okay, and that's going to be lead. Now, if it has more than 1 charge, you have to use the Roman numeral. So it's lead-2. We could have done a lead-4, but I told you we want to stick with the simplest one. Lead-2 chloride. Okay, question now, is it soluble? We come over here and we see chlorine is soluble with everything except these 3, and lead is one of them. So that is not soluble. Okay, next is strontium hydroxide. So we're going to come over here and see that strontium is a 2+. It's in the second row over. It's alkaline earth. It wants to throw off 2 electrons. Now, hydroxide is not an element, so we have to come over to our ions table. And we see hydroxide right here. And hydroxide has a -1 charge. It wants to take in 1 electron. So strontium wants to give off 2. Hydroxide only wants to take in 1, so you need 2 hydroxides to catch both of the electrons that the strontium throws off. So we go ahead and we write that as Sr OH in parentheses, since it's 2 together, 2. You need 2 OHs. You just put the 2 without the parentheses, it means the H is a 2, but the O is still a 1. Now everything, there's 2 of these, 2 of both, okay? All right, strontium only has 1 possible charge, so you don't need to use a Roman numeral, so it's strontium hydroxide. Okay, now, is it soluble? So we come over to our solubility rules. Hydroxide is insoluble. It's in the insoluble column, but there's 3 exceptions. This and strontium and this, so strontium is one of the exceptions. So strontium hydroxide is soluble. Okay, lithium carbonate. So we'll come over here. There's lithium, it's a +1. So it wants to give up 1 electron. We got to go back to our pink sheet or our orange sheet, and carbonate is right here, and it's a 2-. So it wants to take in 2 electrons, but the lithium only wants to each lithium only throws away 1, so you need 2 lithiums to make the carbonate happy. Okay, so it can catch its 2 electrons, you need 2 lithiums. Each one throws off 1 electron. So it's going to be Li2, then in parentheses, CO3. And I take that back. You did not need to put that in parentheses because there's nothing outside. You only needed 1 carbonate. So you don't need to put the parentheses there. It's not necessary, but it doesn't really make it wrong either, okay? So it's lithium. Lithium has only 1 charge state. And lithium carbonate. Okay, now we go to our solubility rules again, and we're looking for carbonate. And carbonate is in the insoluble column, but lithium is one of those that always overrides that. Lithium will disassociate with anything, so lithium carbonate is soluble. I could have written yes, right? Yes. Okay, there you go. Okay, silver and bromine. So let's come over here. So silver, even though it's a transition metal, it only has 1 charge state. It's a +1. So we don't have to use a Roman numeral with it. Okay, and so it's silver and bromine. And bromine is a -1. So those 2 match up perfectly. So it's just simply AgBr. And you just call that silver bromide. Okay, and then we go to solubility rules. And there you see bromine is soluble, but it has 3 exceptions, and one of them is silver. So silver bromide is insoluble. I'll put a no, it's not soluble. Okay, keep going. Iron and sulfur, it should be iron and sulfur. It's not a sulfate. So let's change that to sulfur, UR. So iron and sulfur. So we'll come over here. So iron has 2 possible charge states. If we can, we'll use the smaller number just because that's what we said we would do. And sulfur is a 2-. So the 2+, the iron 2+, and the 2- match up perfectly. This one gives off 2 electrons. This one catches or takes in 2 electrons. So they match up perfectly. So it's FeS. So iron sulfide. Now we go to our solubility rules. Okay, and it says that sulfur is insoluble except when one of the exceptions exists, but none of those exceptions exist, so it's insoluble. Iron sulfide is insoluble, so I'm going to put no, it's not soluble. Okay, lead acetate. So we look over here for lead. It's Pb, it can either be a 2 or a 4, and we're going to use the simplest one if we can. And we come over, now we're going to have to go back to our orange sheet because this is not an element, it's a compound. And there it is, it's in set 3, acetate. So acetate is a -1. So acetate's a -1, and lead, we can see it again up here, is a +2. So this is going to throw off 2 electrons. You're going to need 2 different acetate molecules to catch those 2. So the lead, and we got to say which lead it is since it has more than one possible charge. Well, I'm sorry, we do that over here. Never mind. So it's Pb, that's a 2+, and then the acetate is, we're going to write it this way for no particular reason. And then you got to put that in parentheses because we said you need 2 of those. So you need 2 acetates to catch the 2 electrons that Pb is going to throw off, because each acetate can only take in 1. So you got to put the whole thing in parentheses and put a 2 right there. So what that is going to be is lead, 2, acetate. And is it soluble? So let's go to our solubility rules. And up here, there's acetate. It's soluble for pretty much anything. So we're going to say, yes, that is soluble. Okay, barium, and again, I don't want to put nitrate, it's nitrogen. We're just talking about the pure element and how they're going to combine in an ionic bond. So we come to our charges. Barium is a 2+. It's going to get rid of 2 electrons. Nitrogen is a 3-. It's going to take in 3 electrons. So since 2 and 3 don't go into each other evenly, we need to find a least common multiple. So let's go ahead and write that. So we have barium, 2+, nitrogen, 3-, and we're going to use our crisscross rule. So this comes down here, and this comes over here. So we have Ba3, N2. Okay, so the -3s of nitrogen, you got 2 of those. -3 times 2 is -6. Barium is a +2 times 3 is +6. So +6 and -6 balance out. So now we come over here, and that's just going to be barium, nitride. Okay, so soluble or insoluble? So come over here, and barium. Well, here's what I'm looking at here. Barium is an alkaline earth metal. It doesn't give us anything. I'm trying to see if I'm missing something here. Oh, you know what? I messed up. I did mean for that to be nitrate in this case, okay? So it is an NO3. So sorry, I'm going to write this one down below. Okay, so let's start this one over again. Take 2. Okay, so barium is a 2+, and I did mean for that to be nitrate, NO3, and that's a 1-. So now you need 2 of these. Each of these is going to catch 1 electron. This guy's going to throw off 2, so you need a second nitrate for that, okay? So it's going to be Ba, parenthesis, NO3, close parenthesis, and then put the 2 on the outside. You need 2 nitrates to make that happen, okay? So again, sorry about that. That should go up there. So that's going to be barium, nitrate. Okay, and solubility, well, we see nitrates are soluble pretty much with everything. No exceptions anywhere that we see. So we're going to say, yeah, that's soluble. Okay, last one. Potassium phosphate. So here we go. So potassium, K is a +1. Phosphate, you got to go to your orange sheet, is right there, is a -3. So you have potassium throwing off 1 electron. Phosphate wants to catch 3 electrons. So you need 3 different potassium atoms, each throwing off 1 electron to make this guy happy. Okay, so this is going to be K3, PO, don't need parentheses, PO4. And now that's balanced. So that's potassium phosphate. And anything with potassium is going to be soluble. There it is, K, soluble. So yes, it's soluble. And that was a yes also. Okay, that's how you do these, guys. We'll keep practicing them. Hopefully it's a little clearer than it was before. And again, it's just like learning a new language. You got to learn the vocabulary, and this is the vocabulary of chemistry. It doesn't come easy, but it will come if you apply yourself, okay? So that's all, and have a good evening. We'll see you in class tomorrow. I'm not giving a quiz tomorrow, so don't worry about quizzes. We'll see you tomorrow.